Hello everyone, I am Mr. Ish. Thank you for joining me for this video. We're looking at an interesting hyperbolic exercise. We have a certain expression here, arc sine or inverse sine hyperbolic tan x is equal to inverse tan hyperbolic sine x. An interesting fact is that this literally is equal to that. If you were to graph them, they are indeed the same functions. They're just two different functions which apparently are the same. Anyhow, we have to express the function here or a function here in terms of a cosine. How do you go about doing that, and what does all of that mean? We have something over here which is equal to that. From this we have to somehow derive a expression for which we can express that in terms of a cosine, and that right there is the exercise, and that right there will be a fun procedure. Arc sine, arc tan are inverse trigonometric functions. Tan h and sine h are hyperbolic functions. Okay, how do we go about doing this? How about this? We have arc sine tan h x. This right here is equal to a function. This right here is equal to a function. They are indeed independent functions. We can make them separately equal to a y. We have arc tan, and then we have sine h x is equal to y. Apparently they're both equal to each other by means of that expression, but individually they're both equal to y because they are independent functions. This right here is a complete function, this here is a complete function. What you can do is express each of these in terms of a trigonometric function. You see you have arc sine, you have arc tan. Take the arc sine, arc tan on the other side and see what happens. You'll have sine of y is equal to tan hx. Here you have tan of y is equal to sine hx. I haven't done anything fancy here, think about it. If sine y is equal to x, then y is equal to arc sine x. That's all I've done. I've taken the original arc sine and I've taken it to the other side and I've attached it to the y, and I've done that for both of the cases. Now from each of these cases over here, put in the definitions or the hyperbolic definitions of the hyperbolic function part. We have a sine of y is equal to, what's the definition of this? You write that in terms of sine hx and cosine hx. You have e to the x minus e to the minus x or e to the x plus e to the minus x. Remember the over 2's for each cancelled out. The tan y is equal to the definition of this, which is e to the x minus e to the minus x over 2. Alright? In each of these cases, this is something over 2, but the over 2's cancel out by means of fraction algebra. You can just cancel them out. So I did not even bother putting them down. So that's exactly what you have. Cross multiply these here and here. And what I'm going to do, you remember this, I'm just removing it to create space. Alright? All I'm doing. Now I'm cross multiplying. I have sine of y multiplying with e to the x plus e to the minus x is equal to e to the x minus e to the minus x. That's the first expression created here. Now bring the 2 here. You have 2 tan of y is equal to e to the x minus e to the minus x. Look, this is e to the x minus e to the minus x. This is exactly the same thing. So now this right here is equal to that. Because they're both equal to the same thing, you can make them equal to each other. You have sine of y, and then you have e to the x plus e to the minus x is equal to 2 tan y. 2 tan y. Now what you can do is bring the 2 on one side and bring the sine y on the other side, and let's do that. And again I'm erasing this for space because you've seen this. All I did over here was cross multiply and you saw that. Bring the 2 on one side and bring the sine y on the other side. I have e to the x plus e to the minus x over 2 is equal to tan y over sine y. This right here is the definition of hyperbolic cosine x, right? E to the x plus e to the minus x divided by 2 is hyperbolic cosine. This right here you can simplify. Think about tan as sine over cosine, and then you have sine over 1. You have sine over cosine times 1 over sine. These cancel out. You have 1 over cosine, which is equal to secant y. All of that is equal to secant y. If you were to simplify this, you'll get a secant y. But secant y is also equal to 1 over cosine y. You can do a flip over here. You can flip everything, make everything a reciprocal. By converting the secant into a cosine, you have to flip that around. You'll have cosine y is equal to this. You can flip it around. And which is equal to 1 over cosine h, right? 1 over cosine hx, which is the same thing as secant hx. The reciprocal of hyperbolic cosine is a hyperbolic secant, so it's equal to a secant hx, and there it is. you've converted that expression right here, a function, in terms of a cosine, and that's exactly what we've done over here. If you want to take this one step further, you can do y is equal to arc cosine, now we have secant hx. You have now brought this into a form which is similar to this form and this form. Now the interesting thing is all these three are equivalent based on what you are looking at in terms of their domain. But look how this entire procedure worked out. You made this equal to y, that equal to y. You independently brought in their hyperbolic functions. It brought you to this stage where you took everything on the other side, and then you notice that sine y multiplied by this and tan y multiplied by this were equal to the same thing. You made them equal to each other. When you made them equal to each other, that's exactly what you're seeing over here, right here, equal them to each other. You brought the trigonometric functions on one side, and you brought the hyperbolic components on the other side, and then you realize you're looking at this right over here. Hyperbolic cosine is equal to secant. Then we just flipped everything around to make everything in terms of a cosine, not a reciprocal of that, the secant, because the question was to convert everything in terms of cosine, not in secant. And we did the reciprocal of everything. We get cosine y is equal to hyperbolic secant, and then we solve for y is equal to that. Now let's get back to what I was saying not too long ago. This is equal to that, which is equal to that, based on what you look at in terms of the domain, and we'll show you that graphically, and I'm going to erase all of this. And that will bring us to the closure of this video. If you look at the graph of this in terms of an xy plane, you have this right here, pi over 2 horizontal asymptote, you have minus pi over 2. Look over here, this arc sine, hyperbolic tan, arc tan, hyperbolic sine, these are all made of individual odd function components. This is odd function, odd function, odd function, odd function, and they both have a graph which looks like this, like that. That's what the graph of this expression looks like, and that's what the graph of this expression looks like. Two functions which are superimposed on each other, which is why they're equal to each other, and they both have an intersection here at the origin. Think about it, hyperbolic tan of 0 is a 0, arc sine of a 0 is a 0. Hyperbolic sine of a 0 is a 0, arc tan of that 0 is a 0. Now what does this look like in terms of a graph? It looks exactly like what you're seeing here, but since this is made up of two separate even functions, you don't have a negative here in terms of the range. It then, for this part, flips upwards and it carries on. So from a domain of 0 going up to infinity, all these three functions are equivalent. But for a domain from minus infinity going up to 0, I won't include 0 here specifically. Actually, we even can, it doesn't matter. Then this function right here assumes this curvature, and it becomes an even representation. It's an even function, symmetric about the y-axis, whereas these are odd functions, symmetric about the origin. But there it is. These three are all equivalent functions for this domain right over here. They're just not equivalent for this part right over here because of the odd function and the even function nature of these functions. And that right there is the end of this video. Thank you for watching. Have a nice day.